Okay, let's take a look at the policy that's available to us with Zscaler Internet Access. And before we start, we'll look at the different resources that are available. So we'll start with looking at the firewall filtering, network services, applications, IPs, and application services available. Then we'll look at the different access control resources, URL categories, bandwidth, time intervals, and labels, data loss prevention, engines and dictionaries, our forwarding methods, and location management. So within an access control, we have our URL categories. These define the URL categories that come as default as part of the platform. But we can edit these URL categories, we can add categories, we can add URLs to override categories if we need to. So I have a number of different category options, some custom defined ones. I can define things that are my custom whitelists, custom block lists, and this is where I would come to do that. If I look at bandwidth classes, if I'm implementing bandwidth management, I can define certain domains into my different bandwidth classes. I can define what is a large file. And I have some definitions of web conferencing, whether or not Microsoft Live Meeting or GoToMeeting are considered web conferencing applications, and VoIP for Skype. I might also define things that are time intervals. So when I want to apply policy, I could say evening is, in this case, 4 till 8, or the working day is 9 till 5, whatever that's applicable to my organization. I can have multiple time intervals. And then rule labels, whilst you can give every rule a free-form name, I might want to have a specific label for certain categories of rules. For example, business critical rules, for example, or default block rules. If we come across and we look at the firewall filtering, we have some predefined network services. So network services are the layer 4 rules for firewall, so standard IP and port-based rules. So DNS is defined as port 53. And I can group those together if I want to apply policy based on a service group. Things that are important to me, I can group all the HTTP applications together and call them web services. Network applications are the application definitions that come as part of the deep packet inspection that gives us our layer 7 firewall functionality. So as we inspect the payload as it comes through, we can identify peer-to-peer, or we can inspect and identify Filetopia, and it comes into a category peer-to-peer. There are a bunch of application groups already defined. I can add my own by grouping those applications together, and again I can do the same with DNS applications. IP and FQDN groups are those definitions, source IPs being specific IP addresses or specific range that I want to apply policy in my firewall, or destination, again IPs or groups where it could be an IP address, could be an FQDN, or it could be a wildcard domain, or we could just base it on the country level information that we get from our GeoIP database and looking at the destination IP address. And then IP pool are the IP pools that we might use for subjugating or using a synthetic IP address when we're doing DNS inspection and subjugating the Zscaler private access IP for the real IP when we want to pass that traffic through from Zscaler Internet Access through to Zscaler private access. So these are the resources that I have available to me. If we look at forwarding, there's the source IP address information. So I can add IP addresses, static IP addresses for GRE tunnels, VPN credentials, and things like that, and then allocate those to my location. So here I have a location called Milton Keynes. This is my source IP address that I've added, and I might then make a decision to enable things like authentication, of course, whether the firewall policy is enabled, if I have bandwidth control enabled, if there's a private service edge enabled, and if IPS control is enabled. Use XFF from the client request if there is a request from an on-premise proxy coming through from this source IP address. We'll consume the X forwarded for in that header and log that as the client IP address for the transaction rather than the public IP address that we see the traffic coming from. We can group those locations together if we want to apply policy based on those location groups. Other things are applicable for locations and forwarding rules. If I want to forward from Zscaler Internet Access to Zscaler Private Access, where Zscaler Internet Access is doing the inspection or some kind of policy enforcement and then passing it through Zscaler Private Access for either private application access or source IP anchoring, then I would define this here. This needs to be defined in conjunction with the private access piece. I may have decisions where I want to forward to an upstream proxy. There are use cases where a customer uses a proxy in the cloud that chains from Zscaler. So the traffic flow comes from the user, from the client on the user to Zscaler. Zscaler does our inspection capability and then maybe forwards to an upstream proxy that might do additional functionality such as logging payload, which of course Zscaler doesn't do. And once it's passed through that upstream proxy, then it egresses to the destination website. So you define that upstream proxy here, and then we will use the policy construct to make a decision how to handle that traffic. So think of the things under administration, our resources. These are the definitions, our locations, our layer 4 or layer 7 firewall definitions, our URL categories and bandwidth control definitions here that we're going to use elsewhere. And then finally, the DLP dictionaries and engines. There are a bunch of predefined dictionaries, credit card numbers, social security numbers. I can define my own. And then the DLP engines group those together into an engine that I will use in my DLP definitions. For example, PCI compliant says if it has more than one or more than zero, one or more social security number and a credit card in there, then that will trigger our PCI compliance, and then we can make policy decisions based on that. So once I have all my resources defined, I can come into my policy engine. And we'll start here with URL, cloud and app control. So here I have a very simple policy. It's just going to block adult material for this specific group of users. So let's take a look at this, and you'll see a standard format. The URL filtering rules will have a standard. When I add a rule, I can put it in a specific order, which administrator or which ranks of administrators are allowed to edit or change this rule. I have that free form rule name that I'd place in here, whether the rule is enabled or not, but then I could apply one of those rule labels that I've defined. For a URL filtering rule, I have criteria, which are those URL categories. They could be the predefined ones or the custom categories. So it's important to take note that these are ANDed together. So this rule, the criteria, so the rule would trigger for if the URL category is adult material and the user is, for example, Mark Ryan, or the user is in group internet, or the user is in department children. So these are logical ORs for this group, and it's ANDed together here. And then I can say if the location is a road warrior or one of my groups for IoT traffic, for example, and then again that logical AND for the request method. I have a number of different HTTP methods that I can make a decision on. I might make a different decision if it's a GET request versus a POST request, for example. These ones are ANDed together. So again, the request is this, and the time is one of my time periods, and the protocol is HTTP or HTTPS. So these ones are logically ORed together, and the user agent is Microsoft Edge. So I can start to build a very granular policy here. And then finally the devices. We know that Mark Ryan is using Cloud Connector, or there's some device groups which tell us more information about it. So we could say he's just on a Windows device for these things. So I can build my criteria quite granularly for a web filtering rule. I can also make a rule that expires. The rule will only be active at a certain point in time. Again, I might align this with my DevOps framework, for example, if I want users to only be able to access certain services for a short period of time, and then the rule expires. And then actions, I can say the rule will either trigger as an allow, and I can put a bandwidth quota on it. I can caution the user, which means that the user needs to accept that caution page before they're allowed to look at it. I can specifically block the page, and I can allow override. And in this case, the override user has to authenticate. So when we override a transaction, it's going to prompt the user for another authentication round, redirect the user to the IDP when we're using SAML. The override user will log in, and if that credential matches here, or they're in a specific group for that user, then that override would apply. An example of this is if we were doing it for schools, where the teacher could be in the override group to allow access to certain categories based on their discretion. So I can have multiple rules. Rules run top down, first match to fire, and then we move on. Cloud App Policy is the more Web 2.0 dynamic applications. So we have a number of definitions here. I could add for example, a finance application. And within those finance application, we've got a list of our finance applications that we understand. And again, we can select that cloud application, or we could say that cloud application has a risk profile that we defined within our administration page. Again, down to users, groups, departments, locations, all of these are logically ORed together. And again, we have that rule expiration ability, and again, we can allow or block. We also have the ability to isolate traffic. I should have covered this in the URL filtering policy as well. So with isolate, I can say I select an isolation policy here. Let's take a look at file type control. So file type control is I would define it as a blunt tool to prevent the download of files to a user's device, as well as the ability to prevent users uploading files. So again, we have that same rule definition types, the file types, different files that we identify based on the content type, the MIME type, and the magic bytes from that file and the extension. So we can select a file, select our archive files, and we can say, is this upload, download, or both? Again, do we allow, block, or caution before this file is allowed to be transmitted? This will only apply to the web protocols. Take a look at bandwidth control. When we're in a fixed location that has an amount of bandwidth defined, I can apply a bandwidth control to make sure that my business critical applications take priority, or I can look at the inverse and say that the streaming traffic doesn't consume a certain amount of bandwidth. So in a bandwidth control, again, I have a rule, header information, the criteria, those classes that were defined under resources. Again, for specific location, when it applies, again, it applies for certain web protocols. And then we can define how much bandwidth is available, minimum amount of bandwidth. If it's a mission critical application, I want to guarantee, at least 50% of my bandwidth is available for this. Or if it's a streaming application, I want to curtail it to say the maximum is 20% of the available bandwidth. And then we'll give regular flow control of that traffic based on those priorities. SSL inspection policy is important. We want to inspect all traffic. Here I can make a decision whether my O365 and UCAS is enabled. The Zscaler recommended bypass to bypass applications that we know will don't function when SSL inspection is enabled. And then I can define my specific these are the auto-generated whitelist. Again, applications that shouldn't be inspected because we know that things will break. And then my default policy says inspect everything else, perform URL, inspect everything else, do untrusted certificate checks, perform a certificate revocation check on those certificates for those websites, block undecryptable traffic, and maintain my minimum client and server TLS versions. So again, if I add a inspection rule, I have that rule definition at the top. Again, my criteria, URL categories are either or together with the cloud application, the destination groups that I might have defined, the forwarding gateways if I'm using that upstream traffic, again, ANDed with the locations, ANDed with the users or the groups or the departments, the group types for the devices, and whether or not we should apply it for users that are using Kerberos authentication, and if we see different user agent types. And then my action, if these things trigger, should I inspect, do not inspect, or block the transaction without performing SSL inspection. And what should I do with that untrusted server certificate? So if we're doing that OCSP check, or there's a invalidity with the certificate, with a date and time of the certificate issuer, or the canonical name on the certificate not matching the FQDN in the browser, then it becomes an untrusted certificate. And what should we do? Should we then pass that error all the way through to the client, or what? Let's take a look at our malware policy. So malware policy, invariably we'll leave this as default. We want to inspect traffic inbound and outbound. We want to do it for all of our web traffic, and we want to block all malware, the different types of malware, and the different types of spyware and adware. If we look at the advanced threat protection, again, we're probably going to leave this as default. We want to block all of these transaction types, malicious traffic, fraudulent traffic, tunneling traffic, vulnerabilities like cross-site scripting. We can have a blunt tool to block suspicious destinations based on our GeoIP database from Iran, North Korea, Russia, Syria, you name your country that you may feel that it's just dangerous to let people connect to those things. Whether we should block peer-to-peer file sharing or voice traffic. And then the Zscaler page risk score analyzes every object on every page and generates a dynamic score for that page. So that dynamic score is based on where the traffic has come from, where it's gone to, the age of the website, the history of that website, whether we've seen malicious traffic from that website in the past. And we're doing that for every single object on the page. So does the object use obfuscated JavaScript? Is it instrumenting cross-site scripting? Things like that. That'll generate this risk score, and then our confidence for whether or not that file is high risk. So if it's all the way over here on the right, that file or that object on that page, 100 says we've got 100% confidence that that file is risky, it should be blocked. 0, we have a 0% confidence that it's malicious, or we could look at it the other way, 100% confidence it's not malicious. And so if we have a 30%, there are indicators on the file or the object that it's malicious, but it doesn't go past 30, then we'll treat it as benign and allow it to come through, and it'll pass through other inspection engines. So generally we want to see this around 30. This is a company's tolerance for risk and those files. Let's take a look at security exceptions. So if I have a website or a transaction, a URI, where I say this is a false positive, or I specifically want to override the blocks that Zscaler is doing, I will add this here. It is worth understanding that if I add something here for threat protection, it also bypasses on the malware protection as well. My sandbox control defines what objects will go into the sandbox for inspection there, and how we will behave with those. So if we look at this rule, again, standard rule header, the criteria, the file types, the categories, the users, the groups, departments, locations, groups, and then what categories within our sandbox analysis are going to pass through. Again, which web protocols it's going to apply for, and then how we're going to handle those transactions. Should we allow the file through on its first download and scan the file, and then if there's a block because it's malicious, we need to go and remediate that. We can make a allow and do not scan, so just basically bypass the sandbox entirely, or we can say quarantine, and quarantine says block the file for the user, sandbox it, allow the sandbox to process. Once the sandbox has processed, then we either allow or deny it based on the result there. We can also enable AI-based quarantine, so to use our artificial intelligence to inspect the file quicker, make some decisions quicker, even though it might still go into the sandbox. So it's a faster method of processing that file, has a high efficacy of success, but isn't as comprehensive as passing the file still all the way through the sandbox. Once the file has been identified, if it is malicious, should we allow or block that file based on the decision criteria? And then within browser control, we can use a blunt object to allow or deny certain browsers based on our corporate policy. So we'll only allow through specific browsers based on the browser user agent, specific browsers, versions of Chrome, and Firefox, Safari, and Opera. So we support the generic, relatively newer browsers, and we'll add more to it as they come along. So let's take a look at data loss prevention. Again, our data loss prevention engine enables us to add rules with or without content inspection. So we'll add a rule with content inspection. Again, the standard header. Our criteria is that engine that we defined. So we define our PCI engine. We're going to apply that PCI engine to specific URL categories. Again, our cloud applications, certain file types. We're going to set a minimum file size to trigger the rule. If it's a credit card number, and a social security number, 0 is a good size. If it's a PDF document that might have source code in it, you might want to have a larger data size. Whether it's going to apply to certain users, groups, departments, locations, again, your different requirements. You might want sales folks to send PDF documents with quotes out, but not anybody else. Or people in the finance team might be able to send certain documents to certain destinations or certain users, but not allow everybody else. So again, your policy constructs are going to come in here. We can have the Zscaler incident receiver. Zscaler is going to scan that content. We can integrate with ICAP services as well. And I don't have an incident receiver here for that to receive that payload and inspect as well. The action, do I allow or block? And then if we detects something, which auditor should be told. So I define auditors again under my resources tab as specific users, or I can use an external auditor and put a specific email address, and that auditor will receive an information about the block, or if you allowed the transaction, but also the payload. So if it triggered, this is how we notify people that a trigger happened. Again, rules, process, top down, first match. So under the firewall filtering, we can make a firewall control decision. Got a number of defined applications here, but let's look at these. I can insert a rule at a higher order level, give it a rule name and a rule label, and so it's worth understanding these criteria here are logically ORed together. So this user or this group, this department, this location to make this trigger. And then logically ANDed across, so specific network services groups or the specific network service. So I might say, for example, HTTP, which tells me it's port 80, and then application, I might say the application is HTTP in here as well. HTTP proxy or tunnel traffic, so we detect this with layer 7, so I can combine these, so it's port 80 and HTTP. I can base it on source IPs or source IP groups that I defined previously in resources, or statically define some IP addresses in here, and then my destination IP that I might filter on here as well. And then I make a decision. Do I allow the transaction? Do I silently drop the transaction? Do I send an ICMP port unreachable back to the client? Or do I send a TCP reset back to the client? And then I can make a decision. Do I log? I do full logging for the transaction, or aggregate logging, which is statistical logging. This rule triggered 5 times in the last 10 minutes, and log just a single line for that. My NAT control policy, relatively similar. Again, that rule information, the same criteria for who, what, and where. Those network services or source IP and those destination IPs. So all of these criteria trigger what should I do with that packet. So I might do a DNAT to 1.1.1.1 or whatever, or I could do a dnat.company.com and it will do a DNS resolution for that. And we'll pick one of those IPs that it resolves to and pass the traffic through. I might also do a translation of the port, so a port address translation. So I change port 80 to port 8080 on the egress, for example. The policy, I can have a look at my DNS control. It's important to understand that Zscaler client might intercept the DNS, or if I'm sending traffic from a tunnel, we can have the DNS come through. Zscaler will intercept all of those DNS packets, and Zscaler becomes the DNS resolver. So I can, with my resolution, so it's important to understand that with my Zscaler client connector, we're going to intercept DNS, and it's going to come through Zscaler Internet Access. I might have a GRE or an IPsec tunnel. I might have a GRE or an IPsec tunnel, and my DNS will flow into the tunnel, and Zscaler will intercept that when it hits the Zero Trust Exchange. So Zscaler transparently becomes the resolver for that traffic. You don't need to specifically target Zscaler. We will intercept that and re-resolve. So for O365, doing the re-resolution means that we will find the shortest path from the Zscaler service edge to the O365 on-ramp, or if there's CDN traffic, again, we will re-resolve and find the fastest or closest service point based on the Zscaler IP, not the client location where the client might have resolved it. So we find that provides greater service optimization. You might also then, based on this DNS resolution, again, those criteria based on who, the source IP, the destination IP, we can re-resolve. We can say for the DNS application, different DNS tunnels, different groups, IP address information, what the request type was, what protocol was being used, what should we do with this DNS traffic. We might allow it or block it. We might pass it to Zscaler private access, but we might also redirect the request or the response, meaning redirect the response as provide a different answer to what it actually resolved to, and therefore the client will try and connect to a different IP address. Redirect the request, we'll send it off to a different DNS server for us to resolve against. FTP control, I can either allow FTP over HTTP or deny it, allow native FTP or deny that, and specific URL categories for FTP, so we can have a very rich control of FTP traffic. And then we also have our IPS control. Within IPS, again, the similar rule types, the criteria, who, where and when, the service types, so we might look at DNS, those groups, and then those threat categories within our IPS engine. Again, source IP and destination IP. And then what are we going to do for this traffic? So when it passes through our IPS engine, if it triggers, should we allow the transaction? Should we block it with a drop or a reset? Or should we specifically bypass the IPS for this transaction? Again, we have full and aggregate logging. And then finally, we have our forwarding control. We make those forwarding decisions, again, based on the general information about the location information, the services and applications, the source IP, and then we make a decision for destination. Should we we look at forwarding control, we can add a forwarding rule, again, same rule, header information, the criteria, specific users or groups, location information or department, those services, what service types, the application types, the source IP information, predefined or statically defined, the destination information by URL category, FQDN or IP address or country, and then we can make a decision up here. Do we allow this to go direct? Do we use our proxy chaining and forward it to an upstream proxy we define in resources? Or do we forward it to ZPA and use the ZPA definition? And we have to select the destination. In this case, it was the IP chicken that we defined, and make a decision to forward it through a specific application segment and a specific definition that we created under resources.